Today we're gonna see about voltage comparator using virtual labs. So first get into virtual labs, electronics and communications, and let's get into analog electronics labs and experiments. So today we are gonna see about voltage comparator in analog electronics using virtual lab. So first let's get started. A. It's about to study the voltage comparator theory introduction. Let's start about introduction. A comparator, as its name implies, compares a signal voltage on one input of an operational amplifier with a known voltage called a reference voltage on the other input. Comparators are used in circuits such as digital interfacing, Smith trigger, discriminator voltage level detector, and oscillators. A comparator circuit is basically an operational amplifier without feedback. That is, the operational amplifier is used in its open loop configuration, and when the input voltage V input exits a preset reference voltage V reference, the output changes state. Due to the very high open loop gain of the operational amplifier, using it with positive feedback or even with no feedback at all causes the output to saturate to its supply rail, producing one of two distinct output voltages depending on the relative values of its two inputs. So there are two comparator. One is non-inverting comparator and the other is inverting comparator. So first see about non-inverting comparator. A fixed reference voltage V reference of 1 volt is applied to the inverting input and time varying signal voltage V input is applied to the non-inverting input as shown in figure. When V input is less than V reference, the output voltage V0 is equal to minus V saturation. And when V input is greater than V reference, then V0 is equal to positive V saturation. Thus, the V0 changes from one saturation level to another. Here's the circuit diagram of non-inverting comparator. The diodes of D1 and D2 protect the operational amplifier from damage due to the excessive input voltage V input. Because of these diodes, the difference input voltage VID of the operational amplifier diodes are called clamp diodes. The resistance R in series with V input is used to limit the current through D1 and D2. To reduce offset problems, a resistance R compass equal to R is connected between the inverting input and V reference. The input and output waveforms are given in figure 2. So this is the input and output waveforms of non-inverting comparator. Next we are going to see about inverting comparator. An inverting comparator in which the reference voltage V reference is applied to the non-inverting input and V input is applied to the inverting input as shown in figure. Here is the figure. In this circuit, V reference is obtained by using a 10K potentiometer that forms a voltage divider with DC supply of positive VCC and a wiper connected to the input. As the wiper is moved towards positive VCC, V reference becomes more positive. Thus, a V reference of a desired amplitude and polarity can be obtained by simply adjusting the 10K potentiometer. So, this is the diagram of inverting comparator. So let's see the input and output waveforms of an inverting comparator. So here is the input and output waveforms of inverting comparator. So after the applications of comparators, so there are four applications. First, null detectors. Second is the zero crossing detectors. Third, relaxation oscillator, and the fourth is window detectors. So first is null detectors. Let's see about null detectors. A null detector identifies when a given value is zero. Comparators are ideal for null detection comparison measurements since they are equivalent to a very high gain amplifier with well-balanced inputs and controlled output limits. The null detector circuit compares two input voltages, an unknown voltage and a reference voltage, usually referred to as VU and VR. The second, zero crossing detectors. For this type of detector, a comparator detects each time an AC pulse changes polarity. The output of the comparator changes state each time the pulse changes its polarity. That is, the output is high for a positive pulse and low for a negative pulse squares the input signal. The third, the relaxation oscillator. A comparator can be used to build a relaxation oscillator. It uses both positive and negative feedback. The positive feedback is a Smith trigger configuration. Allow the trigger is a bistable multivibrator. However, the slow negative feedback added to the trigger by the OC circuit causes the circuit to oscillate automatically. That is, the addition of the OC circuit turns the hysteric bistable multivibrator into an astable multivibrator. The last is window detectors. Comparators can also be used as window detectors. In a window detector, a comparator is used to compare two voltages and determine whether a given input voltage is under voltage or over voltage. So that's all for applications of comparators. Next, we're going to see about procedure. So in procedure, there are 6 steps. So the step 1 is connect the components as mentioned. The step 2 is click on check button to check the connections. If connected connections are wrong, make the right connection as per given instruction. Step 3. If connections are right, click on the start button to perform the experiment. Step 4. Toggle on or off button to control the power to the system. Step 5. Move the voltage range slider to fetch values into table. Step 6. Click on plot button to plot the graph. Next we go into see about simulation. So as I said before, there are two types of comparators. One is inverting and other is non-inverting comparators. So let's get start simulation of inverting comparator.
So this is the circuit diagram of inverting comparator. So let's see the instructions. It gives the connections of components 1 to 3, 2 to 4, 5 to 7 and 6 to 8 and the other check button and the start button. So first we are going to see about giving the connections. So 1 to 3 and 2 to 4, 2 to that is ground, and then next the right side is about 5 to 7 and 6 to 8. We are connected to ground, and then we are about to check the connections. So it notifies as right connections, and it says that you can start your experiment. So now we can start our experiment by clicking the start button. So it's generating the graph. So this is the page where we gonna plot the graph. So first we are gonna on the power button and vary the voltage, and we can set the resistor value 1.1 as 1.2 or like up to 1.4. So when we keep the values as 1.1 or 1.2, the graph will vary. So next we are going to keep 1.3. So next 1.4. So this is the graph of inverting comparator. So when the input voltage is greater than the reference voltage, the output is low. When the input voltage is less than the reference voltage, the output is high. The yellow wave is sine wave and the green wave is square wave. So next we are going to see about non-inverting comparator. So this is the circuit diagram of non-inverting comparator. So as per the instructions, we are going to connect the wires. So it gives us 1 to 3, 2 to 4, 5 to 7 and 6 to 8. So first we are connecting to 1 to 3 and 2 to 4 and then 5 to 7 and then 6 to ground. Next we are going to check connections, and it says the right connections. So you can start your experiment, click OK and then press the start button to generate the graph. So then we can on the power button and we can vary the voltage value as 1.1 up to 1.4, and then we can plot the graph. As same, the yellow wave is sine wave and the green wave is square wave. So as for non-inverting comparator, we can take up to the 1.4 resistor value. So for non-inverting comparator, when the input voltage is greater than the reference voltage, the output is normally high, that is positive saturation. When the input voltage is less than the reference voltage, the output is low, that is minus V saturation. So that's all for the inverting and non-inverting comparator. we can see the graph for both inverting and non-inverting comparator. Thank you.